Section 10, question 5. A function is defined by the formula f of x equals 3x minus x cubed. Find the exact values where the curve meets the x and the y-axis. So for the x-axis, I would make y equal to 0. So that would be 3x minus x cubed is equal to 0. Common factor at x, so it will be x bracket 3 minus x squared is equal to 0. That's x bracket, so rather x equals 0 and 3 minus x squared equals 0. So that will be x squared equals 3 and x will be equal to plus or minus square root of 3. So my 3 points are 0, 0, root 3, 0 and minus root 3, 0. Part B, find the coordinates of the stationary points of the function and determine their nature. Well, first thing that we'll need to do is to differentiate. So that will be 3 minus 3x squared is equal to 0. And at that point I can say stationary points that occur at f dash x equals 0. Can then take out a common factor, so it'll be 3 bracket 1 minus x squared is equal to 0. Divide both sides by 3, I can then do a difference to squares, and that will give me x equals minus 1 and x equals 1. I'm now going to find my y coordinates, so put back in the original function, so f minus 1 is going to be equal to 3 lots of minus 1 minus 1 cubed. It's minus 3, minus 1 cubed is minus 1, but put a minus in front of it and that's plus 1, and that's minus 2. So stationary point 1 then is minus 1 minus 2. I'm then going to find my y coordinate with the stationary point of 1. So that's 3 bracket 1 minus 1 cubed. 3 minus 1, and that's 2. So stationary point 2 then is 1, 2. So again, there's two methods. So first of all, if we look at the double derivative method, so you take the differentiated function, differentiate it again, you get minus 6x. A negative result will be a maximum turning point, a positive result will be a minimum turning point, and again a zero result we can come on to that another time in a different video. So for f double dashed x, well, if x equals minus 1, f double dash minus 1, minus 6 times minus 1 is positive, that's 6. That's therefore a minimum, since f double dash minus 1 is negative, which is the condition for a positive result. I'll then look at the stationary point at 1, sub that into a double derivative, minus 6 times 1 is minus 6, and that's a max since f double dash 1 is negative, and that's the condition for the double derivative being a maximum, that it's a negative value. I'll then look at the nature table method. So my neighbouring values around the stationary points, x equals minus 1 and x equals 1, so minus 2, 0 and 2. So I sub minus 2, 0 and 2 into the differentiated function. If I put in minus 2, I get a negative value, minus 9. If I sub in x equals 0, I get a positive value, and if I sub in x equals 2, I get a negative value. And that gives me a minimum and a maximum, which agrees with the result for the double derivative method. All of which means that I've got a min turning point at minus 1, minus 2, and a max turning point at 1, 2. Part C says, sketch the graph of y equals f of x. So I'm going to take all my information, including my turning points, and the points at which I cut the axis, which will root 3, 0, minus root 3, 0, and 0, 0. So there is my curve, cuts it minus root 3 and root 3, and at the origin, minimum turning point at -1, -2, and a max at 1, 2, and that's final answer.